Hello everyone, welcome to solve this math Olympiad algebra problem, and here we have n minus 6 and its whole power 4 plus n minus 8 and its whole power 4 equals to 16, and we solve this problem for the values of n and our n belongs to z. So here first we rewrite this equation in this form. We have n minus 6 and its whole power 4 plus we rewrite this term as n minus 6 minus 2 and its whole power 4 equals to 16. So here you see that we have n minus 6 with a common term, so that we will take n minus 6 equals to y, and we substitute this value on the above equation, and it will be written as y to the power of 4 plus y minus 2 to the power of 4 equals to 16. And here we again rewrite this equation as y to the power of 4 plus we write this as y minus 2 and its whole square, and its whole square equals to 16. So here first we use the nice square identity in the base term, so it will be written as y to the power of 4 plus y squared plus 4 minus 4 times of y and its whole square equals to 16. So now in the next step we use here the nice formula, and it will be written as a plus b plus c whole square, it is equals to a square plus b square plus c square plus 2 times of ab plus 2 times of bc plus 2 times of ca. So here we use this nice formula on the above term, and you see that this is the value of a, this is the value of b, and this is the value of c. So we substitute these three values in this formula, and we write the above equation as y to the power of 4. So here we open this formula, and it will becomes y to the power of 4 plus we have b square, so our b is 4 and 4 square is 16, and we have c square, so our c is 4y, so for the square of 4y is 16y square. And after that we have 2ab, so we have a is y square and b is 4, so 4 times of 2 becomes 8y square. And here we have 2bc, so our b is 4 and c is minus 4y, so this minus 4 2s are minus 8, and our b is 4, so 8 4s are 32, so it will becomes minus 32 times of y. And after that we have plus 2ca, so our c is minus 4y and a is y square, so it will becomes minus 4y cubed, and 4 2s are 8, it will becomes minus 8y cubed, and this whole equation equals to 16. So now in the next step here we add or subtract the like terms, and we first add these two terms and we obtain 2 times of y to the power of 4. So you see that this is plus 16 and this is plus 16 are cancelled by each other, and here we get minus 8 times of y cubed, so it will becomes minus 8y cubed. And now we add 16y square and 8y square, so it will becomes plus 24y square, and after that we have minus 32 times of y, and this whole equation equals to 0. And now you focus on each term, and you see here we have 2y be the common term, so we take it common and you get y cubed minus 4 times of y square plus 12 times of y minus we have 2 ones are 16 times only 16 because we take common y, and this whole equation equals to 0. So in the next step we convert this into cases. So our first case is we write 2y equals to 0, and the second case is we write y cubed minus 4y square plus 12y minus 16 equals to 0. So in the first case we easily get the value of y equals to 0, And now we back substitute the value of y, and you see here we take our y equals to n minus 6. So we back substitute the value of y here, and we get n minus 6 equals to 0. So here you easily get the first value of n equals to 6. So now in order to find the other values of n, first we find the value of y from this cubic equation, and now we solve this cubic equation by using the synthetic division. So that first we find the root of this equation by inspection. So here you easily see that we have y equals to 2 satisfied this equation. So y equal to be the root of this equation, and now we write the coefficients of this equation and we use the synthetic division process. So we have we write the coefficients of this equation. So the coefficient of y cube is 1, the coefficient of y square is minus 4, the coefficient of y is 12, and the constant term is minus 16. So we proceed this synthetic division by the factor 2. So here first we write this term as it is. So now we multiply this 1 by 2 and we get 2. So minus 4 plus 2 is minus 2. Minus 2 times of 2 becomes minus 4. 12 minus 4 becomes 8. 8 2s are 16, and minus 16 and plus 16 becomes 0. So this shows that we have the remainder is 0. So it means that y equals to 2 is the root of this equation. So now we write the depressed equation. So we have the depressed equation is written as y squared minus 2y plus 8 equals to 0. So here you see that we need only integer solutions. So now first we check that this equation has integer solutions or not. So here we use a discriminant formula. So that first we write the coefficients of this equation, and these are a equals to 1, b equals to minus 2, and c equals to 8. And discriminant formula is written as delta equals to b squared minus 4 times of ac. So here we substitute the values of b, a, and c. So our b is minus 2 squared minus 4 times of a is 1, and c is 8. So you get minus 2 square becomes 4, and 4 8s are 32. So it will becomes minus 28. So this minus 28 shows that it is less than 0. If our delta is less than 0, it means that this equation have complex roots. So it cannot gives us the integers root. So if this equation gives us the complex root, so that we just rejected this case, and we can just proceed here this root, and this is the real root or integer root. So we proceed y equals to 2. So we write this as y equals to 2, and now we back substitute the value of y. So you again see here we have y equals to n minus 6. So we back substitute this value of y here, and it will becomes n minus 6 equals to 2. So you easily get the value of n equals to 8. So we have two integer solutions of this question. So one is n equals to 8, and the other integer solution is n equals to 6. So this is our final answer of this question, and thank you so much for watching this video. Please subscribe to my channel for more exciting videos.